I'm Tom Bocklisch, I'm the lead ML engineer of Last Mile, and I'm developing conversational AI agents, and I'm going to give you a talk about how to build clever chatbots. So who of you has used natural language processing or chatbots before? Just raise your hand. All right, so a quarter or something like that. So if you might know that you can get started quite quickly just by using keywords and rules, right? So matching on certain words, extracting what the user wants to tell you, and then using rules to match what the bot should do next as a next action. But that gets tricky really, really fast. So if your action gets more complicated, if you have more user input, if you have a back and forth between the user and the bot, you will quickly run into the issue of having lots of if and else statements or rules that you cannot get through anymore. And to solve that problem, there are different ways to use machine learning and to employ that for natural language processing as well as for dialogue handling. All right. So here's an example. The user asks that he moved, right? So you told the bot, I just moved, and the bot asks, okay, do you want to change your address with us, right? So the address might be stored in the backend, and now the user tells the bot, okay, it's Oxford Street 20. Okay, now we suggest Oxford Street 20 near Harvard University, but actually that address isn't unique, right? So there's another one in London. So now the user tells us, no, it's not that address, it's the one in London. And now we can use the previous information and his new input, London, and create the correct address that we can then store. And as you can see here, even for the simple example of just changing the address, there are so many different ways users can communicate with your bot. So they can provide the address as a whole right from the beginning. They can provide just parts of the address. They can provide invalid addresses, or maybe not even an address at all. And to handle all of these different cases, you will not you will rule suck at that point, basically. But if you do it right, then conversational AI will dramatically change how your users interact with you. So instead of defining your web page and where you define how the user finds certain informations, so you need to define the user needs to click here and there to get to a certain point on the web page. In a conversational interface, the user defines the flow. So you just assist him and guide him to goal, but the user, by talking to you, tells you what he wants to do, which makes the task of doing certain things way easier for the user. All right, that works. And to develop these conversational assistants, we created an open source, highly scalable machine learning framework that helps you accomplish all of these goals, so analyzing the messages and handling the dialogue, and then basically getting you started really quickly. So the project is on GitHub, so really visit it and use it. So I'm going to show you in a quick example how to use it, but really try it out with your own data, and just even if it is a toy example. And these conversational agents can really be used for quite a lot of use cases. So that you can do customer support, right? You can do assistance. You can basically help your users out in situations where an app or an installation of an app is not really useful. We as Last Mile, as a company, we focus on this conversational AI and developing these systems. But we go a different path than Facebook or Google or Microsoft with their services. We open source all our technology, so that's the goal. And we try to create a community of developers around that. So trying to create a community of developers that are focused on natural language processing for these chatbot type applications. But we're a pretty cool team, so if you want to join us, just talk to me. We've got researchers, engineers, product people, and we're based in Berlin, Edinburgh, and in Beijing as well. All right, so and now I want to deep dive into the architecture of these systems. So how can you build a clever chatbot? So in this example, you can see that the user message comes in and is, what's the weather like tomorrow? And it can come in via text or voice, like using Google Home or Alexa. or a WhatsApp, Facebook Messenger, right? There are a lot of different communication channels. But what happens next is always the same. So we have our natural language understanding component. And the goal here is to get the message and to extract structured information out of that message. So what does the user want to tell us with that message? Right? This includes what is the whole message, so what does the user want to tell us with that, and what pieces of information are in that message. We're going to have a look at that in a minute. And the second part is the dialogue management. So after we've extracted information from a single message, we still need to handle multiple messages, the history, and also outside information we gather. So that component is actually connected to a backend, right? In our case, that is usually a weather API. So in this example, we would extract the information from the user, then handle that in the dialogue, and the dialogue would use structured information to query that backend API, which could be as simple as just providing it with a city and a date to get the current, or to get the weather at that time, at that point in time. And after we found out what our bot is supposed to do next, we need to communicate with the user. And to do that, we use natural language generation. So our dialogue management outputs structured information again, so basically weather, 20 degrees, it's sunny. And now we need to create a sentence out of that the user can understand. So either using voice or using text again, depending on the interface. And if we've done that, then we closed the loop and we got a message back to the user. In this case, it will be sunny and 20 degrees, which I think is quite accurate for today or tomorrow maybe. All right, and now I want to dive a little deeper into the NLU component, which I showed you is open source. The dialogue management component isn't open source yet, but we're working hard on that to achieve that within the next couple of weeks to make that accessible as well. All right, so the natural language understanding component, how does that work? So as still the same example, message comes in, natural language understanding component kicks in. And as I said, we want to find out the intent of that message. So what's the weather like tomorrow? The intent the user wants to convey is request weather. So he wants our bot to provide a weather for a certain date or location. And to do that, we use, first of all, vectorization. So usually that is a word-to-vec model trained using neural networks. And then we convert the words into vectors, which then form the representation for the sentence. And that representation is then used in a classifier. Right, so that classifier can be a really, really simple classifier, just as a linear classifier, an SVM, or something like that, if you just don't have enough data yet. So you can get started really quickly with just a couple of examples. And as soon as you collect more and more data, that model gets more and more complicated. So you can achieve a better accuracy by handling more cases and different words. And the second part is the entity extraction pipeline. So in that sentence, there's the information tomorrow, right? We need to extract that as well to query our database API for the correct date. And to extract that, we use a tokenizer first, right? Splitting each word, splitting the sentence into its own, into the words, and then using a part of speech tagger to assign each word its function within the sentence. Then we use a chunker to combine the different words that are grouped together, label them with their named entities, and then the next step is to extract the entities we actually want from that sentence. So that actually is the whole pipeline to extract entities and intents from a message. All right, and now I want to show you how that NLU component actually works and how you can do these types of extractions with our open source software. So the first thing that happened after we open sourced it, a user wrote a GUI, which is really cool because we just designed it in a way that you need to write JSON files with your sentences and annotate the entities and intent in there. But a user thought that's not a good idea, created a GUI, which is pretty cool. So now you can just look at the sentences, annotate them, and mark the entities within that sentence. So in this case, we have a Mexican as a location, as a cuisine, and center as a location. Okay, so after you've created your data using that, like just as I said, a couple of examples, you can now get started running the actual code. And to do so, you need to define your model, and we call it a pipeline. So there are different components in that pipeline, and each component adds to the result. So we have a natural entity recognition component here, which is called CRF, which is a conditional random field. And then we have an intent featureizer, which, as I said, transforms words into vectors. And then we have a classifier, which in this case is just an SVM. And we're going to use English as a language, so let me execute that, which is quite quick. And then we use that configuration to start a trainer, right? We're loading the data. I didn't show you all the data, but it's about 40 sentences with, I think, 4 intents. So greet, goodbye. You can see that actually here. So firm, goodbye, greet, and restaurant search. And we also got 2 different entities in there, which is cuisine and location. And after a couple of seconds that's trained, it's really quick just because the training data is really, really small. But which is cool for this experiment because we can now just use it. And let's just start with a simpler one, which is just hello. And as you can see, the result is greet here. And the model is quite confident that it's greet, so that's good. We can use different things here. Hey might work as well, right? 20 or I don't know. Hi. So that's pretty good. So now let's try something more advanced. The one that was in here is quite good. So as you can see now, it is a restaurant search now. Model is still quite confident about that, and also the natural entity recognition found the cuisine Italian in that sentence. So we now have structured information about the message the user sent us. What really is missing is the city Vienna. So the model didn't recognize that. And it's just because there was no city in the training data. Right? So there was no location data within the training data that the model could have picked up. So what we can do is we can use another component that is actually pre-trained. So that model already knows how to extract cities, dates, I think times and numbers. And if we now run that again, it will actually not train this NER spacey component, but it will retrain the other components in the same fashion it did just now. And if we run that again, right, we should now see that there are 2 entities here, right? So our first component is still recognizing Italian as a cuisine, but now the other model is also recognizing Vienna as a geopolitical entity, which is really cool because we didn't need to provide any data for these basic entities like dates and cities, and we can get started really, really quickly with that. All right, so that's about it. Cool, we don't need the backup. All right. So now I want to have a quick look at the dialogue manager as well. So now we know that, we know how the natural language understanding works, and now let's have a look at the dialogue handling. So the message is still the same, right? And now we know the entities and intent of that message. And our goal now is to predict the next action of the bot. And we do that by combining it with the state we've captured in the past. And that state is modified by the previous action the bot took, and every incoming result from APIs or other data that we want to capture in that state. And just combining the incoming message and the state will result in the next action. This combination is done by vectorizing the intents, the entities, and the state itself, so making it usable for a machine learning model. And actually this equals sign is a machine learning model itself. So that is an SVM, or if we have more training data for our dialogues, we can use more advanced models here as well. For example, a current neural network like an LSTM or something like that. All right, and that model actually predicts the next action. So it predicts an index of our next action. We need to define all actions our bot can do beforehand, and that model selects the one we're going to execute next. And after we've selected that action can now respond to the user, right, using the natural language generation. And a simple natural language generation you can always use is just templating, which works really well for most use cases. And for this example, it's really good because we can just input the sentence, it will be something and something, right? And then we'll just input the data in there as soon as we need that string. And our action is actually updating the state as well. And when now the next message comes in, we can use that state again, use our machine learning model trained previously on our data set we had of past dialogues, and predict the next action. All right, so now there are some final thoughts I want to convey as well. So natural language processing and chatbots and conversational AI isn't solved yet. So there's still a lot of open challenges out there, and they're quite interesting as well. So what we are working on right now is how to combine different dialogue models. So if you think about a bot that is able to handle chit-chat like, hey, how are you, or greetings, or goodbye, then you need to combine that with a task-oriented model, right? So your bot should do something useful, right? Providing weather information, booking a table in a restaurant, or booking a flight, something like that. And to combine these different models and reuse the chit-chat component is quite an interesting task. There are other challenges as well, like unsupervised multi-language entity recognition. So as soon as you've built your bot, you maybe get some traction, and then you want to convert that bot into a different language, right? And you don't want to start from zero there. You want to have your training data, you want to have your entities, and to make that as smooth as possible is a challenge as well. And then there's dialogue generalization. So there's always dialogues that share certain patterns. For example, if a user asks, what does this mean, or why do you need that information? That is a certain pattern the user can ask for basically any information you request from him. So that's a pattern, and machine learning model should generalize about that. There's a lot of good research out there as well, so if there's a rainy day here in Vienna or wherever you're going to, just have a look at these things, which are really interesting. There's the computational linguistic and deep learning blog post, which is just a good read if you're on a plane or something. Then there's the memory networks paper from a couple of years ago, which is just the basis for all of the state-of-the-art research. And there's end-to-end dialogue systems using RNN, which I think is a paper from last year or the year before. Which goes a little different route, so they don't split the whole system up into natural language understanding and dialogue management, but instead have one component and one model that handles the message till the next action, which is quite cool. The accuracy isn't there yet, so the models aren't as good yet, but I think that's definitely the future and the way to go. And there's mem end-to-end in Python, so if you don't want to read anything, this is a really cool one because you just need to look at it. It's a really cool visualization and an implementation of the end-to-end dialogue systems. So what did I cover? So conversational AI is a big part of the future. So most apps should really just be conversational agents because you don't want to install an app for every airline you fly with, for example. And these deep learning techniques really help to advance the natural language state of the art, as well as the dialogue handling. So we are now actually able to understand, to some certain extent, of course, what the user wants to convey and how we can include that in the dialogue. And open source has been really, really useful for us as a company. So we open sourced right after we've created it, and we're going to do that with the dialogue engine as well as soon as we've created a cool API for it. And I can only suggest you do that if you're developing AI tools, because you get a lot of feedback from the community and the users. All right, that's it from my side. Really get in touch. So if you want to talk about conversational AI, chatbots, or if you have any ideas or suggestions, or if you want to think about a use case and want to know if it's useful for that case, just get in touch, talk to me, or email me, or grab me, or I don't know. Thank you. Yeah.
All right, you use the app. Thank you for that. It's much easier for us to do it with that. One of the most upvoted questions was, in which programming language is your framework written?
All right, so everything is written in Python. So we're using some underlying libraries like Keras or sklearn or Spacey, and all of them are written in Python, so that's why we went with Python as well. So everything is written in Python, but you can actually start a server from NLU that is just an HTTP and REST API, and you can just message, or you just post your messages there, and you will get back a structured output from that message. So you can basically use it from any language as well, but Python is probably the best choice.
And next question is, do you support multi-language, or which languages do you have difficulties with? Are there some, how is it with that?
So I personally worked a lot with German and English and what do we do, Spanish as well. So these are quite well supported also by the underlying libraries. But basically you can start in any language. There's no restriction to that. Because most of the language models that are the underlying, that you actually need to train are based on like Wikipedia or News Corpora, right? And you can basically get a good Wikipedia for every language and train your language model on that and get started with that. So it takes a while, but it gets you started in any language, basically.
Yeah, which actually counts to the next question. If you create the data manually, or how much data is required, you think, how much dialogue to actually learn?
Okay, so dialogue is a really tricky one. It really depends on how complex the interactions are. If it's just FAQ answering, like user asks one question, you provide one answer, then you don't need a lot of training data to cover that. But if it gets more advanced in terms of like form filling, so asking the users multiple questions, like when do you want to book your flight, where should it go, when do you want to come back, do you have any preference of airline, then it gets more complicated and you need more training data. For the simple cases, you can really get started with just a couple of dozen. For more complex cases, you can automatically generate a lot of the possible ways and then just get started from that. So they are not actually user data, but generated data, which just works good in the beginning, but will not cover every use case, obviously.
For me personally, as I'm interested in language besides developing as well, is there still a problem with homonyms or phrases, stuff like that, so that you have like...
Yeah, so there are tons of problems, right? It's
Yeah.
everywhere. And these problems are different in every language, and this is like where it gets a little nitty and gritty. As I said, you can get started really quick in a language, but to really master it, it takes quite a while. And so it's easier in the language that have been explored better in the past, like German and English, but it's harder for languages that aren't that popular.
And also a question was, what is the difference between a chatbot and a dialogue agent?
Right. And I think there is not a huge difference, right? So what you need to do in the back is quite the same. I think chatbot is more focusing on text, I'd say, and dialogue is more focusing, it sounds a little bit more like voice or a robot walking around. But in the end, what you do in the back is quite the same. Although the problem with voice gets a little harder because you need to understand that voice properly. Yeah.
Where does the app, where does Last Mile take all the data for the examples for the weather and stuff like that?
From our customers or for anyone who uses it, we don't take any data, so we don't store it. It's not like Google or Facebook. We don't collect it. You can run it on your own server. You can run it on Google Cloud, and we don't get the data from that. But there's a lot of open source data available. So there are a lot of collections about weather. There's a lot of collections about flight bookings and stuff. And there are also a lot of challenges that are used to compare different dialogue engines, and you can just use that data to train as well.
And also, how and where do you think chatbots will evolve into, or where will they be used?
Right. I think they're really, really useful in certain situations where you have a short interaction with a company and don't want to install their app, for example. So really flying is like the best example because there's so many airlines and every airline requires you to install their app just to download the QR code, anything like that. And it's really annoying. If you just had an app or a chat app, you could just say, give me the QR code and just get it. I think it's just the better user interaction will be the future.
So more for searching, researching, yeah. And okay. Does any one of you have a question unanswered? So I can give you the microphone. Is there maybe something you want to add that you hadn't had time? I'm sorry, I didn't see you. It's not so easy. It's awesome.
Okay. Getting back to the Python part, like Python 2 or Python 3, or is both supported?
They're both, yeah.
Both supported,
yeah.
Wonderful. And interfacing, will it be for like you would install server software, it would be a web endpoint, most likely some sort of REST-based. Are there also other formats based, or can you just write your own serializer and extend the project in this way?
Sure. So we provide an implementation for an HTTP server, where you can just send in the requests, but you can just use the library from Python directly, just sending in the messages using a function call, and then you can wrap that into whatever you like. So, yeah.
Thank you very much.
All right. Another question I have in here, what I overlooked is, how does it work with multiple sentences that refer to each other? Is that working, or do you need more data in the before and then just put that in?
So if the sentences are referring to one another, you need more data. And a usual way to do is to split the sentences and then treat them as one after another. Like just as multiple messages coming in from the user, that works quite well. But if you have more complex interaction between the sentences, you just need more data, but it does work.
Any other questions? All right.
Cool.
For the next state prediction, why aren't you using hidden Markov models? Like SVMs are for multi-classification.
So for our intent prediction, that actually is a multi-class problem, right? So we have multiple intents and want to predict them. We haven't tried I'm not sure if we have tried that before, but it might be a standard implementation as well. So I haven't looked at that, to be honest.
Anyone else?
Cool.
Anyone? Any hands? Oh, sorry. You came to me. All right.
Do you have any form of typo handling? So if the user gives a wrong input?
Yeah, we actually do have that. You actually can. That's quite funny. So actually, if the users are using phones, it is actually not too big of a deal anymore, just because there's also already autocorrection in there. So it's not big of a deal anymore. But if your users are using desktops, sometimes they don't have that for some reason. But there are a lot of algorithms out there that can correct that quite good. So the best, it really depends on how much data you have. If you have just a few examples, then you should just use one of the standard algorithms to correct spelling mistakes. If you have enough data, you can just ignore these mistakes and just use the data as it is, and that will work. At least to some extent, right? You need to still recognize the words somehow.
Okay, thank you.
That one?
Cool.
Yep. One question.
Oh, another one.
Hello. Can you, for example, recognize the artist name or a band name? Like AC/DC, I don't know, Beyonce.
So recognize
Is it possible?
Recognize that as an entity, or what do you mean?
Yeah, yes. As
Yeah, sure. You basically
a parameter.
any word group that belongs together and forms one part of a sentence can be recognized.
But you have to train for this.
Yeah,
Do you have to input those names like manually somewhere?
Right. So you don't need
It's
to.
like cities. You have some kind of like a base for it.
Yeah. So that's a very good question. So you don't need to provide all available entity values before, right? So your model doesn't need to know that there's AC/DC, that there's Vienna, or anything else. It just needs to know in which position in a sentence that is usually used. And that is usually enough of an indication that this entity standing there is a group or an artist or something like that. So it doesn't need to know the word itself. It uses parts of the word as well, so is it capitalized and stuff like that, so good information as well. But you don't need to know the word beforehand, so yeah.
So you could actually also learn dialect or words you just use. Because if you just put in a word you just invented, you could just...
Yeah, you could do that. You
and
can
it would
invent
reuse
words.
it.
You
So
can
of course,
invent words.
because
Sure. I mean, that's what's happening in language anyway, right? They're getting new words in and out all the time. Cool.
Right. Yeah, we could... You?
All right, one more.
You wanna... Yep. No?
When you're generating the next state, you said that you take into account previous states. Do you also take into account disregarded other states? So it says, I think this is the intent, but it's possible that it's this one, maybe 25%.
Yeah.
Do you also take that into account?
Right. So actually, what we do is, if you have a look at that example, you can see that there's a ranking down here. So it's not just the topic's intent, but we also know, okay, what is the score of the other intents as well. So we can see if the model is really unsure and just saying, okay, it's 30% that, 30% that. And we actually use that as an input rather than just one hot encoding of. It's the better input, but the other one works quite good as well. So.
My question would be, what are the key differences or benefits compared to with AI, API AI, and where do you see all these frameworks moving in the future?
All right. I mean, the benefit of these online frameworks is that they use all the data they have, and they have a lot more entities that are a lot predefined. Right? So you can use days, times, stuff like that. They have a couple of more than we have. But you always log into that system, right? So you're using that API, and if it's one of your core parts, it's a tricky decision to use that system and to couple yourself to that. And you're always sending all your data to that, right? So if you have sensitive user data, for example, if a user provides you with his age and insurance number and stuff like that, you usually aren't legally allowed to actually do that even. So the best way to do that is then do it on-premise on your own system, care about your data, and keep track of the data yourself.
Yeah.
Hi. Can you go into how you predict the next best answer or question about the sending? You didn't go into that.
Sorry, could you rephrase that?
The first component is the NLP component, and the second one, you say, usually you do this with the if-then, like you do it in API, AI, or such systems. And you're saying you're using machine learning to predict or to come up with the next answer or question from the bot?
Right, so that's really complicated. I had a slide prepared, but it just didn't fit into the talk. So it looks like that. So what you see in the middle is just a stack vector of information. So as I said, you convert all the information into a vector form. So that's that long gray block here in the middle. And what you can see here is then the network. So we use a recurrent neural network. So we feed in one answer, one message from the user after one another. And the recurrent neural network keeps its internal state and keeps track of the dialogue on its own. Then usually you have an action mask here, which just says, okay, at this point in time, this action really shouldn't be executed. It's just a safeguard for some actions you might have. Then we do renormalization to get probabilities again. And then the output here really is just a vector of probabilities for each action. So that is what the network outputs. And then we sample from that action, or just in an applied sense, we just choose the maximum one. And then this loop continues, right? We create an output here, and the information goes back into the neural network and gets reused again. So I probably can't explain it in detail right now because it's just taking too long. But there's a really good paper, so if you give me your details, I can just send you that paper that has a really good explanation of that.
Great. So
right.
thank you. You deserve a break now, I guess.
Yeah.